All right, good. Good morning. Welcome back to Trigonometry. Today we are going to be talking about some special angles. I think we've done this before, but since the shelf said, "Here, make a video about special angles," we're going to make a video about special angles here. All right. So what we have for different angles, we're going to go ahead and draw a box, okay, of side one, okay, and then we have to figure out like we have a little triangle here. Each of the sides is one. We're going to go ahead and figure this thing out. So we know that each of the boxes, each of the corners is 90 degrees. If I cut it in half, we're going to end up with a 45-degree angle. And I've got to figure out the hypotenuse here. So that's going to be the square root of my first side plus my second side. And we're going to end up with the square root of 1 plus 1. So that's the square root of 2. Great. There's where we are. All right. So let's go ahead and draw a little triangle down here with all the little pieces labeled. So we have 1, 1, square root of 2. And then this angle right here that we're looking at, that's going to be pi over 4 or 45 degrees. All right. And we're just going to get what are the 6 trigonometric ratios of this angle. That's all we're going to do here. So I want sine of pi over 4. And we're going to say, okay, that's going to be opposite. So we're looking over, right? That's opposite side. So it's 1 over the hypotenuse, the square root of 2. But we're not going to leave it like that because actually, if I go through and do this, if I go through with my tiny calculator real quick here, I'm just going to type in the square root of 2 and figure that out. The reason why we rationalize denominators is way, way back in the day, we had, so we had to use slide rules. So if the engineer wanted a numerical approximation for what's going on, what we'd have to do is we'd have to do this division problem, 1.414. Let's see, 213. Okay, can we keep going? 213,562. Long division into 1. Okay, and then we have to put the decimal place up and put a whole bunch of zeros here and try to figure out what's going on here. As much fun as this is, I can think of other things that I would rather do. So the way we decided to deal with this is we say, okay, 1 divided by the square root of 2, let's multiply by 1. 2 over root 2. Right, root 2 over 2. So we end up with root 2 over 2. And now I have to do a long division problem if I want a numerical solution. This is before calculators. To 1.414213562. Okay, again, this will be delightful, but at least I know that 2 goes into, well, it doesn't go into 1, but it does go into 14, so I can just start with a 0.7, and then we can go from there. Okay, you guys have calculators now, so you might rightly be thinking, like, hey, we are in the 21st century. Why are we doing this? Because some of your teachers learned in the 20th century, and they prefer this arrangement. They prefer it to look the way it's supposed to look. So we're going to go ahead and do that. A lot of times Alex will expect you to write it in this particular way. So we're going to go ahead and we're going to rationalize denominators. There's a reason. There's another reason for this too. It just kind of gets you used to multiplying by 1 and kind of changing the shapes of things. So there's other reasons why we would do this. Okay, cosine of pi over 4. We can go back up here and look and say, well, cosine is adjacent over the hypotenuse. So that's again going to be 1 over the square root of 2. So this is 1 divided by the square root of 2. But again, we're not going to leave it like that. We're going to say that's going to be the square root of 2 over 2. Okay. Tangent of 45 degrees, okay, or pi over 4, is going to be opposite, right, over adjacent. So we can go ahead and say something like, I'm looking for my highlighter. There we go. So I could say it's my opposite over my adjacent. We could go ahead and do it that way. So we're going to say that's 1 over 1 equals 1. And then, of course, we have to do the other one. So that's going to be cotangent of pi over 4. Reciprocal of 1 is 1. We need the secant of theta. We need the secant of pi over 4. Let's get an eraser with that one. Okay. So the secant of pi over 4. Okay, instead of 1 over the square root of 2, it's going to be the square root of 2 over 1. We only have to rationalize denominators, not numerators. So you can leave this alone. And again, the cosecant of pi over 4 is going to be the reciprocal of the sine. So that's just going to be the square root of 2 over 1. Okay, and that's how these things go. So that is the special angle 45 degrees, or pi over 4. Okay, there's another special angle I'm going to start off by, let me go ahead and draw you an equilateral triangle here. Okay, equilateral, all the sides are 2. Why did you start them as 2? You'll see in a minute. All of the degrees here, all of the angles are all 60 degrees or pi over 3. Okay, I'm going to take one of these triangles, take this triangle, and I'm going to cut it in half, right? Because the way I had it before, it was 60, 60, 60. That's not a right triangle. Right now, we can only do trigonometry on right triangles. So it's a thing you have to remember. It has to be a right triangle or this ain't going to work. Okay. In a later chapter, you will learn what to do if it's not a right triangle. We can go ahead and get around that. But for now, you're stuck with it has to be a right triangle. So if I take this triangle and push it down the middle and make it half of it, then I'm going to end up with a right triangle, which is now you know why I'm changing this to be a 2 because I'm cutting this side in half. So I got 1 over here and 1 over there. Okay, so that makes the numbers kind of nice to work out with. And this angle right here, over here, this is still a pi over 3 or a 60 degrees. Okay, let's go ahead and extract this triangle, right, from my big triangle here. So we have, here's our pi over 3, here's our 60 degrees, and I know that the hypotenuse is 2, the adjacent side is 1, and I have to figure out how is this altitude going to happen. So remember, it's a squared plus b squared is equal to c squared. The adjacent side is 1, a for adjacent. I don't know the b squared is equal to the hypotenuse squared. So that's going to be 2 squared equals 4. So we subtract 1 from both sides. We have b squared is equal to 3. B must be the square root of 3. So this side here is the square root of 3. So for a 60-degree triangle, or for a 60-degree angle rather, we have sine of pi over 3. That's equal to the opposite. So again, we're looking at the opposite side, square root of 3 divided by 2. Okay, cosine of pi over 3, that's going to be 1 over 2, right? Tangent of pi over 3, 60 degrees, that's going to be the opposite over the adjacent, square root of 3 divided by 1. So just the square root of 3, right? And now we have to go ahead and figure out what the reciprocal functions are. So I want the cotangent, that's 1 over the square root of 3. I'm not going to leave it like that. We want rationalized denominators here. That's going to be the square root of 3 over 3. Okay. The secant of 60 degrees, that's going to be 2. 2 over 1, but you could just write down 2. The cosecant of pi over 3 is going to be 2 over the square root of 3. And just like with the tangent, we're going to multiply square root of 3 over square root of 3. And we end up with 2 square roots of 3, square root of 3 times square root of 3 over 3. Okay, and that's how we're going to go with this next. So that is our special angle. That's a 60-degree special angle. We're not quite done with this triangle because I cut it in half, making one of these 60 degrees a 30-degree triangle. This guy up here, right, this piece up here, this is a 30-degree triangle, and we know what all the little pieces are. So if I go ahead and push this thing down, say, okay, here's my triangle. Remember my hypotenuse was 2. My altitude here was square root of 3, and then this piece here was 1. And now I'm looking at this as pi over 6, or 30 degrees. Okay, so we're looking at this angle down here. As I don't want the eraser, I want this guy right here. So I'm looking at this angle down here in order to figure out what's going to happen here. Right? So we're just looking at it crossways. So we're just going to say, okay, we want sine pi over 6, opposite over hypotenuse. That's going to be 1 over 2. Cosine of 30 degrees, that's going to be adjacent over hypotenuse. That's going to be the square root of 3 over 2. And of course, the tangent of pi over 6 is going to be the opposite over the adjacent, which is 1 over square root of 3. We're not going to leave it like that. We're just going to say this is square root of 3 over 3. The cotangent of pi over 6, or 30 degrees, is going to be the reciprocal. It's going to be square root of 3. The secant of 30 degrees is going to be 2 over the square root of 3, but we're not going to leave it like that. We're going to rationalize our denominator and say this is 2 root 3 over 3. And then finally, we have cosecant of pi over 6, and that's going to be 2. Okay? And those are our special angles. So we have the 3 special angles. We have 30 degrees, pi over 6, 45 degrees, pi over 4, and 60 degrees, pi over 3. Now, I'm not going to take your calculators away from you. Okay, I can't really do that. These are like the basic angles that show up on the unit triangle all the time. A lot of the early trigonometry textbooks use these angles extensively. Engineering books use these angles extensively. So knowing these values is a really good thing to do. Okay, and I think I showed you guys this before too, but just, you needed to memorize these. You don't for this class, but you could. I wouldn't be sad if you ended up memorizing these things. We have 0, pi over 6, pi over 4, pi over 3, and pi over 2. Okay, so we're going to go ahead and type these guys in. So we want the sine of pi over 6. We know that's a half. Square root of pi of 45 degrees, that's square root of 2 over 2. Square root of 3, that's going to be square root of 3 over 2. And then pi over 2, right, that's 90 degrees. So what are we going to do here? We are going to look at a triangle, right? And here's my angle. And what I'm going to do is I'm going to take this triangle and I'm going to this hypotenuse is like 1. What I'm going to do is I'm going to take this opposite side and I'm going to squeeze it all the way over here. So we actually end up with this as an angle. It's kind of a degenerate angle where the opposite side is 1 and the hypotenuse is also 1. So we end up with 1 over 1. Okay. Uh, the opposite side for a 0-degree angle. So again, we have a triangle here, and I'm going to shrink this guy down. And I just think compress this guy all the way down. So when I'm done, we pretty much have a triangle that's laying flat on the ground. The opposite side is 0. So the sine of that opposite side is 0. Okay, but we're going to make it look like, because this has a lot of square roots in it. So let's go ahead and make them look like a lot of square roots. So this is a square root of 0 over 2. That's still 0. This will be the square root of 1 over 2. This is the square root of 2 over 2. The square root of 3 over 2. And now we have to get with 1. Okay, what am I going to do there? Well, fancy way to write 1 is really 2 over 2. And a fancy way to write 2 is the square root of 4 over 2. So we have the square root of 4 over 2. So now you have a way of memorizing these angles. That's for sine. For cosine, okay, they go backwards. So this is the square root of 4 over 2, square root of 3 over 2, square root of 2 over 2. These have to match up. Square root of 1 over 2, and the square root of none over 2. That will also give you the cosine. Okay, to get to the tangent, once you have these two columns here, the tangent, I'm going to take the sine divided by the cosine. I went 0 over, I don't really care, 0. I want 1/2 divided by the square root of 3 over 2. That's going to be 1/2 times, that's going to be 1/2 times 2 over root 3. The 2's cancel. We end up with 1 over root 3, but we know that that is root 3 over 3. Okay. Uh, Tangent of 45 degrees, I'm going to take sine over cosine. Well, they're both the square root of 2 over 2. Dividing them, we get 1. Okay. And then here we have square root of 3 over 2 divided by 1/2. Square root of 3 over 2 divided by 1/2. That's square root of 3 over 2 times 2 over 1. Stuff cancels. We actually end up with this square root of 3. Now, the last one is 90 degrees. You have to say, well, we have sine over cosine. Cosine is going to be 0, so we're divided by 0 here. This is undefined. When we get to graphing, we'll deal a little bit more with this, but right now it's undefined. But here is a nice, easy chart. So if you ever had to memorize these formulas, you have like a little cheat way of memorizing it where you didn't really memorize it. They have a pattern. Use the pattern. Okay, so we're going to let that go and do that. So I'm going to go ahead and say that's probably good enough for this video. So there's your special angles. You don't have to memorize them for my class, but someday some teachers will expect you to have memorized them. It's nice to have them at the ready. So take care, and we'll see you in the next video. All right, thank you for watching.